improvement EI function to obtain the acquisition function. And this equation formulation consists of an exploitation term and exploration term. Okay, so as an example of BO, now I would like to show you some exercise on such mathematical function like this. And this function consists of a high mountain with a target maximum value here, and a valley and a dummy hill with a local maximum value. And in the right-hand side, this figure shows the contour line of Z. And we gave these 6 prior information as the points you can see here. And in this case, we did not give the prior information on mountain, but on the local dummy hill, so that BO could easily fall into the wrong local maximum. And here is the contour lines, and the observed points will be shown here. And these are the distributions of the posterior mean and standard deviation of the function and acquisition function. So you can see one point here in the acquisition function. So next step will be here. And for the first step here, and second step, third step, here has the largest value in the prior information. At the same time, the variance around the dummy hill became smaller and smaller. And now you can see the acquisition function is high except the dummy hill. And on the next 7th move, BO starts to BO move to exploration phase and search for the different point like this. And this continues for a while like this. And after the 12th move, BO found a part of mountain. And BO predicts the average function has a maximum value near the mountain, and continues the search around here, like this. And after the 15th move, nearly the maximum value was found. Okay, so this is a practical experimental procedure. A disc-shaped 40% potassium sample was prepared from mechanically alloyed powder. And this powder was spark plasma sintered with different processing parameters. Lamp rate X, heating temperature Y, and dwell time Z were used to optimize JC by BO. So, firstly, several prior data were input, and we measured JC of a sample predicted by acquisition function, like this. And then we recalculate GP and make the sample according to the processing parameter suggested by BO. And this was repeated again and again. And we used this BoxVia software, which was produced by our co-authors. So this page summarizes the progress of BO to date. So far, we have prepared about 20 to 30 samples like these. These are the sample preparation parameters in 3-dimensional process. And in the right-hand side, you can see the field dependence of JC at 5K for about selected 10 samples. And the JC for the prior data is quite extreme conditions, edgy conditions, show quite small JC like this. But for other samples, JC ranges between 10 to the 4th to 5th under raw field. And so far, the best JC obtained during Bayesian process was 1.1 times 10 to the 5th amps per centimeters at these strange parameters. Okay, now I would like to move to the second topic. So, as Michael introduced in the previous session, so far, several groups reported that smaller grain size would be the key for JC of 1 to 2 randomly oriented polycrystalline samples. And the group of Vienna proposed such Josephson junction model, and also Shimada of Tohoku reported such relationship between JC and inverse grain size. So these show smaller grain size would be better for JC in theoretically and experimentally. So naturally, we try to synthesize ultra-fine grain in barium 122 samples by increasing the milling energy. And you could see the STEM images show the grain size became smaller from up to 1 micron down to 20 to 100 nanometers. As far as I know, this is one of the smallest grain size among barium 122 bonds. On the other hand, if you look at JC as a function of milling energy, you can see a beautiful dome shape. So JC showed maximum for average grain size, and we observed reduction of JC for ultra-fine grain size sample. So we did detailed structural analysis by SEM. So these are the three-dimensional electron microscopy data for samples with higher JC and fine grain sample. And these 3D images revealed that in the sample with fine grain size, anomalous growth of secondary particle occurred, and also interparticle structures are significantly different. And this may extrinsically limit the JC of fine grain sample. And this important microstructure feature was quantified total path length of porosity. And if we analyze such three-dimensional structural data by using the adaptive thresholding method, we could do further detailed analysis of microstructure 1 to 2 polycrystal. Okay, this is the summary of my talk. Thank you very much for your kind attention.
Maybe I can ask, Aki, if you do this grain refinement, do you see a different field dependence of JC, not only the zero, you just presented the zero field JC. Do you also have data in field?
We did. Today I do not have data, but field dependence also changes much. Also, magnetic distance group changes much. Maybe I would like to ask your advice later.
Okay, thanks, Aki.
So I have one small question. Do you also measure the trapped field of this sample?
This time we performed such Bayesian optimization and also process design by experts on small scale samples, 7 millimeter or 10 millimeter. So maybe we could not anticipate high drop speed. So right now we are planning to make larger size samples using the obtained best conditions from these Bayesian optimization and expert process design. And hopefully we could report abstract field data end of this year or next year.
Okay, thank you very much.